Alrighty, we're going to do the next thing here, and so what we're going to learn about is inverse trigonometric ratios. That's what we're going to work on. Okay? And so this is how we write our inverses. We're not going to write inverse tangent, inverse sine. We're going to write this. Let's go in the right order. Okay, all this means is inverse sine. Okay, so basically how inverses work, they're kind of opposites. So if I were to do this, this would equal 1. Kind of like when you do, a problem like this. And then you do the inverse of 4/3, which is 3/4. What's that going to equal? Okay. So they're kind of reciprocals of each other, but the proper term is inverses, and we're going to see how that works. So what you do is you're going to use this to find sides. You can't see? Okay. So we're going to use sine, cosine, and tangent to find sides. We're going to use the inverse to find, anybody have a guess? Yep, angles. Okay, so that's basically what we're going to do, and so I'm going to set you up with a pretty easy problem here, and we'll see if we can, find an angle. So here's our triangle. I don't want to, let me put it under this one. That way people don't think that we're finding something. All right. So I'll call this 20, and I'll call this 21. And I want to know what this angle is. Okay, so we need to know how to set this up. So first of all, I need to go through all the stuff and things and go, this is opposite, this is adjacent, and this is hypotenuse. So which tool do you think we're going to use? Tangent, right? So tangent of x equals opposite over adjacent. Okay. Well, I want x by itself, right? And that's why you use inverses, just like this problem right here. What do you do to both sides? You take away 4. You do the same thing to both sides. So what I'm going to do here is I'm going to do the inverse tangent to both sides. So if I do the inverse tangent to this side, all of a sudden it's gone. And then I do the inverse tangent to this side, and there we go. Okay, how do you put that in the calculator? That's probably the question. I think we need that. So let's see here. Second, we got to turn it on. Second, tangent. See how it did that? And then I just type in that fraction. And and I get 43.6. 43.6 degrees. See if that messes with its focus. Nope, it does fine. So that's basically what we're going to do there. Okay, the next concept that we're going to do, and it's really the same concept, is we are going to solve right triangles. We are going to solve right triangles. And I'll draw the triangle. What does that mean to solve a right triangle? Is, well, we find all three angles and all three sides. Okay? So I might have a problem just like this. Okay. So what do you think I need to solve? Okay. I probably need to solve, well, I got a number there and a number there and an angle there. So I probably need to solve like A, and I probably need to solve B, and I probably need to solve this C. So I have three problems I need to solve. Do I have to use trigonometry to solve them all? Can we use any tool we know? Could I use Pythagorean theorem maybe to solve for the sides? Okay. We could. But I probably am going to start out with some trigonometry because to find the angles, at least the first angle, I'm going to have to use trigonometry. So I'm going to start out looking for A. And so to find A, I know that this is opposite, this is adjacent, and this is hypotenuse from A. So let's just start there. Well, I have two numbers here, so I'm probably going to use tangent again. So tangent of A equals what is it? Opposite over adjacent. Okay? And then we learn the step that we're supposed to do. A is going to equal inverse tangent 2/3. Put that in the calculator and we're going to come up with A. A equals what? It looks to me like I got 33.7 degrees. Make sure you put degrees so you know that you're finding an angle. Okay, so I found my angle. How would I find angle B, but I don't want to do trig this time? How would I find angle B without using trig? Could I do 180 minus 90, because it's a right triangle, so I only have 90 degrees left, minus 33.7, and I get 56.3. Does that work? So that's not really trig, that's more like arithmetic, right? Okay. Now how am I going to find C? Could we use the Pythagorean theorem? We could. I don't want to, because I would rather just do trig, but some people could use the Pythagorean theorem, where you do c squared equals 3 squared plus 2 squared. That'll work. Okay, but I'm going to go ahead and just do the trig part. So I'm going to use the same angle. I'm going to use angle A. So, and I need to find the hypotenuse. So I'm going to just do, I'll just use sine because I don't know what else to use. Sine sounds like a good idea. So sine of A is going to equal opposite over hypotenuse. So I don't know what it is, so I'll put little c as my variable. Could I have done this instead? And I'll put it up here. Could I have done cosine of 33.7 equals 3 over c? Would that get you the same answer? Does that make sense? Because this one I just use the adjacent over c. This one I use the opposite over c. I'd get the same answer, right? In theory. Okay, so I'm going to switch places here. So c is going to equal 2 sine 33.7. And what's that going to be? .6. Is that right? Questions? It basically became 3 problems. What makes this hard is you can start anywhere you want to. You have to come up with a plan, and you have to think about, based on the given information, what you need to do. But I found all 3 things I needed, right? So like if I wanted to write my solved triangle, I got 3, I got 2, I got 3.6. I have 90 degrees, I got 33.7, and I got 56.3. So that's basically the answer, right? Okay, let's move on. A lot of people get confused on the first part of our homework, and so I want you to turn to page 455. And we're going to do 3. Okay, this is designed to help you kind of think what things mean. Okay, so basically what this says, determine which of the 2 acute angles has a given ratio. So it wants to know cosine of what? Cosine of which angle equals 4/5. Okay. Well, how would I make 4/5 out of some of these sides? Because clearly I don't have a 4 and a 5, but this is a simplified fraction. Is there any of these things that might... So you're saying that 8 and 10 would reduce down to 4/5? Okay, so I have to use 8 and 10. Okay, so 10 is going to be definitely the hypotenuse, right? And with cosine, what do I want? Adjacent or opposite? I want adjacent and opposite. So which angle is this adjacent to? So the answer is angle C. You see how we did that? It's kind of weird, backwards thinking. Okay, now that we've done 3, I'm going to do 7, because there's going to be some of you that are going to look at 7 and you're going to try to make this into a hard problem, and it's not. Okay, it says angle D is an acute angle. Use a calculator to approximate the measurement of angle D. Do it to the nearest tenth of a degree. Okay? What do you think I need to do? Do I need to draw a triangle? Probably not. Do I need to do this? And put it in the calculator? Is that it? Yeah, that's it. So see if you can get D equals 48.6 rounded. Of course, I need to put degrees. Okay, don't make 7 hard. And of course, 13. Well, we just did an example just like 13. I'm going to turn this off. It's too